Hello. So we're continuing on with arrays in this virtual lecture. So we're going to really just use them now. Previously, we just talked about how to declare them and what they are in memory. This whole idea of it's a contiguous block of memory where every element is the same size in terms of number of bytes, so the same data type. But now we're actually going to use the arrays and start manipulating the data within them. So we can't go through a lot of examples because it just takes a lot of time to go through one particular example. But for that, I refer to you to look at the chapter 7, the slide 7 notes. They do have a lot of examples within them. So definitely take a look at those examples. But I'm going to pick out some particular topics and use some of the examples myself. What we're going to continue off with first is really just stepping back a little bit and looking at the array syntax that we can use. So Java itself is, as we've explained before, based on the C and C++ programming languages. Those languages were really meant as workhorses in terms of programming. C is definitely the language if you want to program in operating systems in almost every platform, whether it's Windows or Mac or Linux, Unix, VMS systems, IBM mainframes. C is the language you definitely need to know. It's the all-purpose language. Because of that all-purposeness, it uses a lot of fluid syntax for various things. And one of them is arrays. And C++, of course, use that idea. Java uses the idea as well. Other languages and scripting languages have very rigid array structure syntax. And the reason for that is they need to be very clear as to what's being explained. So what you will see in Java is that you'll see that this type of syntax, that we want to declare an array here called prices, and we're going to indicate to Java that it's called prices, and the data type is an array of float. You could also declare it this way. You could say, hey, I want to create an array called prices, and each element is going to be of type float. So the first form is actually the proper form. So this is the proper form of how you should declare it. So the very first line. And the reason for that is very similar to if we wanted to declare, um, let's say, just a simple integer. So we would declare that as int and age. So the way we declare this in Java is we provide the data type first, and then we provide the identifier name. So whatever it's going to be called in our program. So whenever we're going to reference the age. So Java then sets apart 4 bytes of memory, and it refers to it as age. So that's the proper syntax that we need to use when we're declaring an array. So we declare and say, I'm going to create an array of type float, and that's exactly what that syntax is telling Java, that this is going to create a reference to an array of float types. And we're going to call that reference prices. So we're going to store the address of that array in prices. This syntax down here is a little misleading. It says I'm going to create something of data type float. It just happens to be an array called prices. So Java then has to understand, oh, I'm not creating a single int or a single float data type. I'm actually creating an array of those data types, which is the alternate syntax. So this is not very friendly. It's still viable. You can still use it, and we'll see it in some other contexts soon, where we're going to be looking at passing arrays as parameters to methods, and you can use this syntax as well. But the proper syntax is this one. So where we declare the array called prices, and we provide its data type called float array. Very similar to how we declare an int variable like this. So just to point out that yes, this will compile, this format will compile, but it's not the proper way to write it. It's much better to use the proper way to write it, to declare the data type first and then the identifier, which is exactly how we've been using everything from now on, or everything previously, where we declared a string name. That's how we did it. So let's take a look at another example of using an array and actually see how we can manipulate. So it doesn't mean just putting data into it, but really getting the data back out of it. So let's take a look at something that we've probably been wondering since the very beginning of the course. So I'm going to create a very small little program here and start manipulating an array. An array we've actually seen from the beginning of the course. So here we have a simple program class called simple array. And it doesn't actually do anything yet. You can see that the main is completely empty. But there is an array here. It's called string args. So that is an array. We've never been able to use it before. We've never had a reason to use it, but we know that we have to type it in. If we don't provide it, if we don't actually type this in, we can compile the program. There's nothing wrong syntactically. It's got the class, it's got a method here called main, but when we try and run it, Java tells us this class does not have a static void main method accepting an array of string. And now we know that this syntax means an array of string. So it means that Java can't find the method that matches this appropriate signature. The signature being that the name is called main and that there is at least one parameter, or there is exactly only one parameter, which is an array of string. So the header here is missing that. So let's put it back in. And we'll use the proper array syntax. So we say it's an array of string, and we call the array args. We could call this array anything. We could call it Bob if we wanted to. There's nothing wrong with what we call it, but now the signature of the method matches, so when we run it, this program runs correctly. Obviously, as I pointed out, it doesn't do anything yet. So all we have is a method which accomplishes nothing. But let's put that back to the common form, which is string args. So what is that array called string args? What is it? How does it get used? Well, there's at least one thing we know about an array, which is its length. We don't know exactly what's inside it yet, but we know that we can call the length. So let's display that. Let's add that to the program itself. There we go. And you know that we're not using a method called length. That is an attribute of the array itself. So just dot length. It's not dot length with parentheses. That would be a method call. We're just using the attribute called length to actually get the length. So this will display the length of the array. So let's see how long this array is. This array called args. Well, it's of length 0. Okay, that doesn't help us much, but it does tell us that this array has no data within it. It has no elements. It is a valid array in memory, it just happens to have no element data. This is different from an array which is null. So this array has no data in it. So where does this data actually reside? Where does it get called? Well, when we're using Dr. Java, if we remember, Dr. Java is just an integrated development environment. When we're running our programs, actually even when we're compiling them, this is happening with the Java compiler when we do the compilation and the Java virtual machine when we're doing the running. All Dr. Java does is provide us a nice little environment where we can see our editing up in the top screen and then we can see our output in the bottom part. Well, this isn't actually Java. If we open a command line, then we can actually start looking at what Java does. So let's do that. So we will just open up a command window in Windows here. So we see a command prompt, and let me move that over to the screen that we're playing with. There we go. And we'll put it into the same place as where this program is getting compiled. And we can see that up in the name that is in a folder called Java Playing, also a folder called Array Examples, and what we should see is we've got down here our simple array program. So we've got our simple array.java, our simple array.class, and then we have our backup file, which is not really important. But we've got our source code here is the Java, and we've got the class file. So we can take a look at our Java program. So simple array.java, and there it is. So that should match the program we've got here. So simple array, public static void main string args, system.out.println, and so on. So it's the exact same program. And then we've also got the class file as well. So if we wanted to run the class file, we could just say Java simple array. We don't put the .class in there. For running it, we just put in the name of the class. And what we should see is that it's exactly the same as what we had when we ran it in Dr. Java. So this is actually how the program is running. It's actually executing within a window or a command line. So where am I going with this? Where are we talking about this length of args and the fact that it's 0? Well, let's change this up a little bit. Let's run this program and type in, let's see, hello. Now the length is 1. So I've actually provided a piece of information here. So the array itself, when we run it simply with no, what we have as a parameter, so we just say Java simple array, the string args here is a value of 0, which means it's no data. But now we actually typed in a piece of information, hello, and our length is 1, which means this is actually part of the array called args in main. So let's go back to this program. So when the Java virtual machine runs this program called simple array, it's going to find automatically the main method. That's what it means to be a program class. You have a main method. What it passes to the main method as a parameter, because this is what this is, it's a parameter, just like the methods we've been calling. What does it pass into it? Well, normally it passes nothing into it because it's given no information. So it's the same as when we run the program like this. When we execute it by just saying simple or Java simple array, we provide no parameters and we just tell Java execute this program. No information is passed into the args array parameter. But if we provide some information at the command line, for example, the word hello, that is going to get passed into the array. So this array now has one element in it, one element value. What is it? It's a string. How do we know that? Because that's what we've defined the array to be. String args. It's an array of string. So let's actually display this array of string, and let's do it as a for loop. So actually, before we do it as a for loop, let's just display the first element. So we will ask Java to display the first element in this array. So if we execute it within the Dr. Java environment, we might not get what we want. We end up getting some sort of runtime error. And the reason is we get an array index out of bounds at 0. And the reason is when we come in here, the array itself has a length of 0, which we saw previously. If you remember, when we don't provide any parameters, we see 0 here. So what's happening is that the array itself has no data. So we're asking in this statement, please display the first element. Please display the first element of data. Well, there is none, therefore we get an array index out of bounds. There is a way in Dr. Java to provide this information for running the program, but it's much easier to do it at the command line. So in this case, let's run it and give it the simple single parameter. So hello. Now we should see, there we go, that the length of the arguments is 1, and the first value, which is at args 0, gets the value of hello. It's the first string. So this is one way, if not one of the simplest ways, to actually give your program, not just your method, but your entire program, a piece of information, which is at the command line. And this is one of the ways that we actually provide programs, Java programs, information when they first start executing, and it does not require any user input. There is no file that the program needs to read from. It's given the information directly from the command line or whichever program is executing it. So if we had this Java program running within a script environment, let's say it's within a Linux bash shell script, or a Linux batch, or sorry, a Windows batch file script, we could actually provide your program information at the command line and let it go ahead and execute. Let's change this program just a little bit so that we put in that for loop that I mentioned. So now we're going to display all the elements in this array. So we're going to loop I from 0, which is the first element index, to the last one. So in this case, it will loop I up until length -1. So that's what that condition states. And we're going to go through each individual one. And we will display every element at position I, or at index I. So now, if we compile this guy, there we go. And we go down here to running it. So let me clear the screen. And we will run this with hello. What we should see is the length of the argument. So again, it'll be 1 because there's only one parameter here, or one argument, depending on how you look at it. And it should display it on the screen. There we go. So we see 1 hello. Let's try it with hello world. So now we actually have 2 arguments. So we have hello and world, and we see hello and world as each value is getting displayed on its own line. So hello world, this is a test. So hello world, this is a test. So this is actually, if you will, pretty much the whole reason of why we were learning public static void main string args from the beginning of the course. It took everything we've done so far in this course of knowing how program structure works, how methods work, how passing data into methods, how primitives work, how arrays work, how strings work, how systemout.println displays information, how a for loop is actually conducted with its initialization, its condition, and its change. Everything we've done in this course has been to lead up to show you how public static void main string args actually functions, and why you had to type in public static void main string args every single time. This is the reason. It's so that when we create a Java program, we can give the Java program information without requiring user input, and we don't require reading any information from a file. This program can now run standalone, and it can be controlled by something else. So the operating system can control what information. So I think that's actually a very valuable thing to know, especially for Java. Now you're also probably wondering, could you put all this information into one argument? Why does it always have to be separate? Well, you can surround certain things with double quotes. And this is one of the ways to create what they call a single phrase. So now we understand the purpose of these double quotes around strings. So why does it want to make a string like that? So this is how you do it when you're calling it from the command line. Putting double quotes around something creates a single string versus individual strings. And this works for any context that Java is run, whether it's Windows, Macs, Android, Linux, you name it, which operating system. If you have a Java virtual machine, this is how you do it. So congratulations, this is pretty much the whole reason for everything we've learned in this course, how to display something from string args. So this is a very simple program using an array, but also a very, very powerful program of how we can interact with the Java from outside the Java program itself. So I hope you found that actually fairly interesting. So let's look at another example now, and we'll look at passing arrays into a method. We'll see how that works. So here we have a very simple program. Again, it doesn't do anything, and what the purpose will be is to pass an array into a method which will do the display. So let's create a very simple array here of integers. We'll just call it list again, and we'll make it of size, let's say 10. Very, very small little array here. And what we will do is fill it with just random numbers. Let's see, yeah, random numbers should be good. So what we will do is import whatever we need from the util class. So that should get us the random number class and also the scanner class if we need it. So what we will do is a very simple for loop here, which will go from 0 up until the length of the array minus 1 and increment by 1. So we're just going to loop through every element. And what we will do within each one is give it a random value. So what we're going to have to also do is create a random number generator. Just call it rand. And we will assign every element its own random number. So rand, and let's choose from 1 to 5. So it'll be of 5 values plus 1. So that will, if you remember, the very first thing, because next int of 5 returns back a random number 0 through 4. And then the plus 1 is what gives us a random number from 1 to 5. And we could then use another for loop to actually do the display. So we've used one for loop to populate it, and we'll use another for loop to do the display. So let's see, position at I, and then the value which will be list at I. Let's see what that looks like. So there's our random numbers. So we've got, well, that's a crazy little thing. I forgot to actually indicate the value at I. So that's what I wanted to show. So then we'll show the value at that position. That's a little better. If I could type it in properly. Nobody is perfect, clearly. There we go. So at element 0, we get the value 1. At element 1, it's a value 1. At element 2, at element 4, and so on. So we have random numbers from 1 through 5. Let's run it one more time. Let's actually see. Yeah, there we go. So we didn't see the 4 the very first time, but now we do it. So we have random numbers. We could change this up a little bit. Let's say from 1 to 100. Do another compilation just to see what the effect is. And perfect. So we've got some random numbers there. But I wanted to, instead of doing this population here, instead of doing the display here, I wanted to do the display of these values inside of a method. So I didn't want to do my display here. So how could we go ahead and do that? Well, we're going to write another static method within this class. So public static, and this will be a display method. So it won't return anything. We'll just make it a void, and we'll call it display array. Now, what we're going to pass into it is the array itself, and this is going to be an integer array. So we'll just call it numbers, because they're integers. I always like to provide some documentation there. So what are we actually passing into this array? Or sorry, into this method? Well, you'll notice that we're passing in this array here of integer. We're going to call it numbers locally just to the method. But if you remember, we're not actually passing an array here. We're not going to pass all the values into this array. What we're actually going to pass in is just the reference. So this right here, remember this part is not the array. This is the reference to the actual array in memory. At best, list points to the memory address of the first element in the array. At best, that's what it does. In this case, what it means is give me the first element in this array of integers. Give me the memory address for that. Then I know where the rest of the elements are. Because remember, it's a contiguous list of values. So no matter how many elements the array has, once you know the position of the first one, you can reference all the ones after that. So how can we do that easily? Well, pretty much let's just copy this code over here and paste it down below. That should be pretty much it. The only difference being we don't call the array list anymore, we call it numbers. So we're going to change that to numbers. And then, of course, we have to actually make the call. So we're going to call the method called displayArray, and we're going to pass into it list. So let's put some comments here. Display all the values in the array, whatever it happens to be. So let's take a look at what that effect is. And there we have our random numbers again. So we have them showing up here as just like they did before. Nothing too fancy. We've reduced the size of our main method. Now it just does this population here, and it does the display. Let's say we wanted to display the array again. We could just, we could just copy it one more time and just say display it a second time. And now we've shown the list twice. So we started at 0, an element index 0, and then an element index 0 again. Now, this doesn't look like anything fancy. Why didn't we just keep the display in there? What if we wanted to display a different array? So let's go in and create another one. We'll call this another list, if you will. We'll make this one different size. We'll make it of size 20. We will go through and do the same effect. So what we will do is copy this right here, and we will let's see, change that to another, and we will make this a random number. Let's make it more like a coin flip. So this will only have one of two values, either value 1 or value 2. So this will be value 1 or value 2. And let's display another. Now you'll notice all we've done in the main method is we've just used this loop right here to populate this new array. Let's make sure we do that properly. There we go. So we've populated this other array, so another array here with a loop, but to display it, we just pass in the reference to the array. So then this method gets the reference, it calls it numbers, whatever it happens to be. This will point to a different array in memory, which has a different length and a different set of values. So now let's see what happens. Let's put in a simple systemout.println to separate the output to make it a little clearer. And let's put a little dash in there. So that should be really clear as to what gets displayed. So you'll see we've got our first array called list. So let's scroll up a little bit or scroll down a little bit to list. And we see that we've got our display here. So we display list first of all. It's got only 10 elements in it, 0 through 9. And then we display another. Now that one has 20, 0 through 19. And it simulates a coin flip. So all its values are either 1 or 2. Yet the method doesn't really have to change. All the method cares about is I'm pointing or I'm referencing an array of integers. That's what gets passed in the argument. And what it then does is just displays it. It doesn't care how the array got populated, nor cares what the values are, as long as it's an array of integer. That's all it cares about. So this is a very simple example of how we can pass an array into a method. Keeping in mind, we don't actually pass the entire array in. All we're passing is just the reference to the array, not the array itself. An interesting aspect about this is extremely fast. In other programming languages, when you pass an array to a method or what they call a subroutine or a function, the language will actually have to make a copy of all the data. So if there's only 20 elements in the array, it actually happens very quickly. If there were 2 million elements in the array, the method would actually have to get a copy of the array, all 2 million elements. So the language itself, as it's executing that statement, would have to take time to make a copy of those 2 million elements in an array. My apologies for stumbling on that. which means also that the environment has to have enough memory to make a copy of that array. Java, on the other hand, doesn't have to worry about that. It just goes ahead and says, why don't you just pass the reference in? The array will stay in memory, it won't get moved, it won't get changed, but here's where it's located, and I'll pass in the reference to the array, not the array itself. And this is extremely fast now. So display array can then process that array really quickly and stop and return back to the main method. Java and C and C++ all use this idea, and so do some other languages. Yet some scripting languages use the idea of making a copy. It's just something to be aware of, and also something to be very cautious of when we're using arrays in Java. And we'll go through what that means to be cautious of. Because what happens if we're just passing in the reference? Can we change the data in the array? And yes, we can. This idea of populating the array, which we're using a for loop in the main, why couldn't we use a method to do that? And yes, we can. So let me clean up this code, and we'll come back to creating a method which populates the values in the array. So we've still got our same program here, but we've got the main method which populates the array for list, and then it populates the array for another. But why couldn't we use a method to do this population? Now we'll keep the display array. It works exactly as it should. It's perfect. But now let's write a brand new method which will populate the array. Now you'll notice I'm making it a void method, which means this method doesn't return anything. But yet I want it to accomplish something. I want it to fill this array with values, yet it's going to be void. And the reason is I'm just passing in the array reference. So we'll call the array itself, we'll call it values. And what it's going to do, since it's only getting the reference to the array, not the array itself, it can manipulate the data within. So let's take a look at what that does. So let's take a copy of this one. We'll move it down here. And we will change this to be values, because that's what the method is calling the array locally. And that's it. So this will be the end of populate. So let's see what happens here. We will then call it. So we will say populate list. So we're calling populate list. We're passing in the reference to the array called list, and it is of 10 elements. So we've declared the array in memory. So Java has put aside these 10 integers. It's calling the first element, or the entire array. We're going to refer to it as list. We're passing in that reference into the method called populate, and it's going to get passed in and called values locally. So we have two things at this point pointing back to the array. In the main method, it's referred to as list. In the method populate, it's referred to as values. So then we're going to go through a for loop, which then says I'm going to loop through all the quote unquote values in the array, and I'm going to set everything to a random number. And if you've noticed something, that we'll have a problem as soon as we compile this. Yes, we do. What is rand? Well, if you notice, populate fills up the array with random values, but rand is actually something we had up in the main. So we're going to move this from the main method. Since the main method isn't going to do any population, we'll move it down here, which means for the moment, I'm going to comment out this population of another array. So it should just have a bunch of 0 values. And since I don't want to display it, I will comment out the display. Let's focus on just the list method right here. Or sorry, the list array. So we're going to populate it, fill it with random values from 1 to 5. or sorry, 1 to 100. Let's take out this comment here, and let's see what happens. So we've got some cleanup to do in the code just to make sure that everything can appear on the screen. There we go. So let's do one more compilation, and we will run it. And what we should have is, there we go. So we've got all 10 of our values filled with random numbers from 1 to 100. Excellent. So we've got this idea of a method getting passed in the reference to the array and able to manipulate the data in the array. And then we've also got the idea of doing the display of those values, the exact same concept of passing in the reference to the array, but in this case, we're not changing them, we're just displaying them. So this is how we can populate an array with data. We can manipulate the array, change its values, and manipulate it in the sense of pulling the data back out. So if you will, this is an input into the array, and the display array is the output from the array. So let's add a comment here. We'll call this one, let's see, populate array with random values. Now there is one problem, of course. Let's put this back in for another array, and we want to display it. Now for another array, we wanted to populate it with values 1 or 2. So random values 1 or 2. We didn't want to populate it with random values of 1 to 100. So how can we change this method called populate to only get the type of random values we want? Well, why don't we just change the parameter and give it the possibility of saying, I want to pick the number of values. And if we're thinking about it as a coin flip or a random die, with the random die we called it sides. So this is the number of random sides. So we will go in here, we will say sides. So this populates it from 1 to sides. So if we then are able to call it correctly, what we should have, for list we wanted values from 1 to 100, yet for another we wanted values 1 to 2. So now we've got our main method. It looks pretty clean actually from what it looked like before with all those for loops. So now we call the method populate. We pass into it the reference to the first array, which is only 10 elements. Then we pass in the reference to another array, which is 20 elements. For the first call, we want random values 1 to 100. For the second one, we want values 1 or 2. So if we go down here to the populate method, here we have the array reference that we're going to populate, and then the number of sides. So this would be with random values 1 to the number of sides. So we declare a random number generator in the method, then we do a simple for loop for the number of values that we have, and for each value we will populate it with a random value within the range we want. And then what we do is we display the list and we display another list. So let's take a look at what the effect is here. It's exactly as we had before when we had all those for loops within our main method. So we've got all the 1s and 2s for a random number, and then we got the 1 to 100. But if you look at our main method, by implementing these methods, populate and display array, we've really made a very clean main method. Also encapsulating the idea within the populate method that populates random values, also in the display array method to display an array. And they don't care. The populate method and the display array method do not care which array it is, as long as it gets called in terms of the parameters. So we've got list and the number of values within the random range, and we've got the other array and the number of values in the random range. And then we just display it. This is a great example of using the idea of a method to encapsulate a concept of either populating or displaying an array. The one caution here is in the populate method. There's an assumption the array is already declared, which means that the memory has to already be put aside for the array that we want to populate. If we look at it, list itself is declared of 10 integers right away as soon as the main begins. With another array, it's declared of an array of 20 integers right away as soon as the main begins, which means the populate method now has somewhere that data can be placed. It's already declared of either 10 or 20 large. But what if it wasn't? If we wanted this populate method to truly encapsulate the idea of creating the array and populating it, this isn't good enough. The populate method requires something. Could we have it where it didn't require it? What if we rewrote it so it looked something like this? So what this means is create an array of 100, fill with 1 or 2. So we'll call the method populate2. So what it will do is both create the array, it will allocate the memory, and then automatically fill it with a value of 1 or 2. What is it going to return back? Well, if we look at this side over here, we have an integer array declaration. We're calling the array reference yet another, which means this has to return back a memory address. So our method called populate2 had better return a memory address. So let's change this up a little bit. I'm going to change this to only 5 elements and a range of 1 to 3. Just to be different from the other arrays up here. So let's do a display of that one. So what will this method called populate2 look like? It's going to be very similar to populate, except in terms of the array, it's not going to get passed in because it doesn't exist yet. The populate method will have to create the array in the first place before it starts populating it. So it's going to have to do a couple of things. Let's take a look at it. So let's save the return value for just a second. We're going to call it populate2. And if we remember up here, we've got the length of the array. So we'll change the comment up here. It's the length of the array and then the value range within for those random values. So the first one is going to be the size of the array. And the second one is going to be essentially the number of sides, very similar to what we had in populate up here. But it does return back something. What does it return back? Well, let's take a look at this again. We declared an array of integers, we call it yet another, and it's going to be assigned the memory address that populate2 returns back. So populate2 needs to return back an array of type integer. So let's just say it returns back an array of type integer. And that's it. This is a proper valid return type because what is an array of integer? It's literally just a memory address. So that's why memory addresses are the 9th mysterious data type. So we have Boolean, byte, short, long, int, char, Boolean. Did I mention float? we have the 8 primitives, and we also have memory address. So what populate2 is returning back is the memory address specifically to an array of type integer. Now inside populate2, we've got to do two things. Number one, we're going to have to do the population, of course, but we also have to do the declaration. Now this is going to be something new. It's called the dynamic array declaration. We don't know how big it is when the method starts, but the method does have a value, and that's size of the array. So we'll call this return list, and it's going to be declared of size of array. So there we go. We've declared locally within this method a brand new array of a size that at the moment of the method, it doesn't know. Up here, it's going to be of size 5, but as far as the method is concerned, it doesn't know how big it is. So it's just going to declare of whatever size the parameter says. Then, of course, we can go ahead and populate it. Now, instead of copy pasting this code, we already have a method that does the populate. So why don't we go ahead and call it? So we're going to call populate with this array that we've just created, and the number of sides is exactly the same as the number of sides here. Now, what do we return back? Well, remember, this array here is referred to as ret list. It's the reference to that array that just got created. That's exactly what we want to return back, is the reference to that array. So let's return back ret list, which is just a memory address. That memory address is what gets returned and stored over here to yet another. So let's put some comments to that note. So this one, populate a new array of size of array with random values 1 to sides. So this declares our dynamic array. This one populates the array, and then this returns the reference to the array. And that's what gets stored up here to yet another. Now, one of the rules that we had in Java was that anything declared locally is gone when the method finishes. Remember, anything local to this, so size of array, sides, even ret list as references, cease to exist once this method is finished. As soon as this return statement happens, or as soon as that brace happens, and control is passed back to the main method, everything local is gone. Size of array is gone, sides is gone, ret list is gone. So what happens to the array itself? Well, the array stays around, and the reason for that is this right here. We're passing back the reference to the array. So once this method finishes, the reference to the array was called ret list, but now it's called yet another. So Java doesn't garbage collect the actual array values. There is something pointing to the array, and that's now called yet another. Inside here, there is nothing that's called ret list, nothing called size of array, nothing called sides. These three identifiers are garbage collected. The memory that these two referred to, those are garbage collected. But the array itself, that is returned back. Another reason of why this concept of pointing to the array rather than having the entire array is very, very efficient for Java. In this case, when it returns back the array, it only returns back the reference to the array. Therefore, this method doesn't take much time. The declaration takes a little time. Calling populate to go through a for loop, that takes a little time. But to return the array itself takes no time at all. So let's take a look at it. So list itself is using the old populate method. So it's going to be 10 elements from 1 to 100. We're going to call the old populate method for another. That's going to be of 20 elements, and that's only going to be 1 or 2. And then we're going to call this populate2 method, our brand new one. It's only got 5 elements in it, and it will have a value of 1, 2, or 3. That's its range. So we just display all 3 of those. Let's take a look at them. So what we should see in our output is the very first one, which is list. That goes 0 through 9, so that's 10 elements. From 1 to 100, seems reasonable. We've got the second one, which is another. That one is from 0 to 19, so that's 20 elements. All values are 1 or 2. And then we've got the very last one, which is only 5 elements, 0 through 14, and it has random values 1, 2, or 3, and we see those. We run it again. We see, well, that's an interesting set of values right there, all 1s. Let's run it one more time. We got some 3s in there now as well. So this is now yet another way of manipulating an array. So we've got the populate method, the old one, which requires the array to get declared before, and then we can populate it. We've got then the populate2 method, which doesn't require the array to get be created beforehand, because it goes ahead and creates the array, and it populates it. Then it returns back the address to the array. This is actually pretty neat. Very, very flexible. And then we've got the display array method, which can display any array of type integer. And here's our methods. We've got the old populate method. So that one expects this to be created immediately. So before it gets called, it goes ahead and populates it. We've got the populate2 method, which only needs the size of the array to create and the number of sides for the randomness. It then creates the array internally, calls the old populate method to actually do the population, and then it returns back the reference to the array, which means we could do one more funky little thing. So let's copy this this out here. We'll change this to some stars so that it looks a little different. Now let's use display array to display an array that populate2 creates, and let's make this one 30 elements long with a range of 1 to 10, and then display it. So display an array of 30, random range 1 to 10. So this statement right here is not only going to declare the array, it's going to populate it and then display it. What happens to the array afterwards? Well, it's pretty much the end of the program anyways, but it would get garbage collected because nothing would point to it. So let's take a look at what that effect is. Oh, and I need to call it populate2. Now we should have our array of 30 elements. There we go, 0 through 29, populated with a range of 1 to 10. So we've got a range of 1 to 10. If this doesn't show you the power of using methods to encapsulate an idea, and also having methods which then call other methods, because each method is truly encapsulating an idea, we've even got the display method, which is doing the display of the array that is getting returned by this method. If this doesn't show you the power of arrays and the power of methods, I'm not quite sure what will. So this is a fantastic example of using arrays and methods together. In the next virtual lecture, which will be the last one, we're going to take a look at how we can use arrays to store objects of classes. And we're going to use the die class and the puppy class. And we are definitely going to be using methods to manipulate those. So don't forget the ideas that we've seen here of allocating arrays inside of methods and then passing in array references in order to do something with them as well, whether it's populate them or display them. I'll see you in the next and last virtual lecture. Bye-bye.